This is the introduction to section 6.5, part 1. And in section 6.5, we're going to discuss conditions of rhombuses, rectangles, and squares. And essentially, what we're going to look at, 6.5 and 6.4 are very similar. In 6.5, these are really just the converses of the theorems we looked at in 6.4 with the properties of rhombuses, rectangles, and squares. So, in other words, we're just trying to use these theorems to prove that this parallelogram is a rectangle, a rhombus, and a square. Okay, so we're going to kind of go through these quick because these are the same types of things that we looked at before. So, very first thing here, very first theorem, theorem 616 says, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Well, before we said it's a rhombus if the diagonals are perpendicular. Well, we know that if the diagonals are perpendicular, then we know for sure that it is a rhombus. We don't need to know that all four sides are equal. We know that if the diagonals are perpendicular, it's going to be a rhombus. Okay, that's the first one. Now, this part down here, we're not going to mess anything with proofs on this anymore, so we're going to go ahead to the next page. Okay, as we look at this page, two other theorems that we're going to look at, 617 and 618. It says, if one diagonal of a parallelogram bisects a pair of opposite angles. Now again, this just has to be, in this case, one diagonal. It doesn't have to necessarily be both. If it bisects a pair of opposite angles, then that parallelogram is a rhombus. Okay? So again, you only have to use one diagonal to prove that it's a rhombus, if it bisects the opposite angles. And then finally, the theorem 618, it says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. You know that if the diagonals here are congruent to each other, then that shape is, or that parallelogram is going to be a rectangle. Okay, so let's take a look here at this example. It says, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Or it may be multiples at one time. Okay? So, as you look at letter A, you know, first of all, you don't see any right angles at all. And if you don't see any right angles, you obviously can eliminate rectangle and square. Now, so this first one, letter A, it does happen to be a rhombus. What is the reason why when we explain? It's because the diagonal, the one diagonal, bisects the opposite angles. Okay? This diagonal right here bisects this angle, and it bisects this angle. Okay? So because the diagonal bisects the angles, we know that that's a rhombus. All right, letter B, we've got a couple different things. You see that the diagonals are perpendicular. Well, you know if the diagonals are perpendicular that you have a rhombus, for sure. But you'll notice you also see that the diagonals all have the same marking, which means that they're all the same length. Well, if the diagonals are congruent, then it's also a rectangle. Okay? Well, if it's a rhombus and it's a rectangle, then as we talked about in class today with section 6.4, we also know that this is a square as well. In this case, it happens to be all three. And my reason is because the diagonals are perpendicular and the diagonals are congruent. So we know it's a rhombus and a rectangle. And because it's a rhombus and a rectangle at the same time, we also know that it is a square. Okay, as we look at a couple more examples here now, it says using properties of special parallelograms, it says for what value of x is parallelogram ABCD a rhombus? Well, in order for this to be a rhombus, you have to know that the diagonal has to bisect the angle B. So in other words, I would know that 6x minus 2 has to equal 4x plus 8. Those two angles have to be equal to each other. Okay, and when I subtract 4x from each side to solve this guy, I get 2x minus 2 equals 8. If I add 2, 2x equals 10, and if I divide by 2, x is going to equal 5. Okay, so you know that the diagonal of a parallelogram, in this case, if it's a rhombus, is going to bisect the angles. Let's take a look at the second one now. What I want you to do here now is I want you to see if you can come up with an answer. Hit pause, come up with the answer, and then hit play, and then you'll hopefully see if you get that answer correct. Okay, now that you've hit pause, for what value of y is parallelogram DEFG a rectangle? Well, what they're giving you here has to deal with the diagonals, and you know that the diagonals are congruent to each other. Okay. You also know that the diagonals, if they're congruent to each other, that each part is going to be equal. So you can now say that 5y plus 3, that part, is going to equal 7y minus 5. And when you solve it, you subtract 5y from each side. You get 3 equals 2y minus 5. Add 5, and 2y is going to now equal 8. And when you divide by 2, y is going to equal 4. Okay. Example 3 and 4 here. It says for what value of x is the figure the given special parallelogram. So this time they're telling you it is a rhombus, and we want to know for what value of x would it be a rhombus. So as you look at this, again, on a rhombus, you know that all the sides are congruent to each other. So when I set this up, it's going to be 8x minus 1 equals 3x plus 9. Subtract 3x, so 5x minus 1 equals 9. Add 1, 5x is going to equal 10. And divide by 5, and x equals 2. Now, if you wanted to check your answer, you could plug that back in, and it should be both the same numbers. 8 times 2 minus 1, that's 15. And if I plug 2 in here, 3 times 2 is 6, plus 9 is also 15. You can always check your answer to see if it's correct. Okay, and the next one, it's a rectangle, so we know that the diagonals are congruent. So even if we just have their parts, 3x minus 5 is going to equal x plus 1. Subtract x, you get 2x minus 5 equals 1. Add 5, 2x is going to equal 6. And divide by 2, x is going to be 3. Okay, so again, this is very similar in section 6.5 to 6.4. Okay, talking about the characteristics and properties of rhombus, rectangle, and squares. And this time in section 6.5, we're showing how to prove that it's a rhombus, a rectangle, or a square using their converses. Okay, this concludes section 6.5, part 1. Don't forget to complete your WSQ.